mathematics is more than just a number, equation, or symbol in a page. It is a way of thinking that shapes every part of history to the modern world.
Throughout history, different mathematicians have viewed mathematics in a unique way, each contributing ideas that change how we understand science, technology, and even logic itself. From abstract reasoning to patterns, structures, and computation, their perspectives reveal that mathematics is a living and evolving discipline.
In this video, we explore the views and contributions of the six great mathematicians. We have Fourier, Gauss, Boole, Wiener, Weyl, and Turing, and how their ideas connect and influence on our world today.
By understanding their perspective, we discover that mathematics is not just a subject in school, but a powerful language that connects our ideas, solve real-world problems, and shape the future.
Let's go back to history.
First, we have Joseph Fourier, who believed that mathematics help us understand how nature works. He said math can reveal the hidden laws behind physical events. His most important idea was breaking complicated signals into simple waves, called the Fourier series and Fourier transform. This idea is now used in many technologies like image and audio compression, signal processing, and communication systems. Fourier also defended his work from critics who tried to claim his ideas. He said real science grows through original discoveries, not by copying others. His legacy shows that mathematics connects different phenomena and helps us see the patterns that shape our world.
Here we have Carl Friedrich Gauss, who believed that mathematics was the queen of the sciences, a title that reflects how he viewed its power and importance. To Gauss, mathematics wasn't just another subject. It was this discipline that guides, shapes, and strengthens every other scientific field. Whether in physics, engineering, astronomy, or economics, math provides the logical foundation and precise tools that allows other sciences to grow. These beliefs show how deeply Gauss valued the clarity, reliability, and the universal truths that mathematics offers. He is known as the Prince of Mathematicians. Gauss contributed heavily to number theory, which is essential in modern cryptography and secure online transactions. He also developed the method of least squares, now used in statistics, data science, machine learning, surveying, economics, and all fields involving prediction and data modeling.
This is George Boole, who believed that mathematics is abstract, a system of symbols that do not need fixed meanings. Instead of limiting algebra to numbers, he used algebraic symbols to represent logic, such as true and false. This led to the creation of Boolean algebra, which later became the foundation of digital circuits, binary, logic, and modern computers. Boole's abstract approach changed mathematics completely. By freeing algebra from arithmetic, he showed that symbols can be combined to express ideas and reasoning. This new way of thinking gave mathematics a wider scope and more power, influencing technology and computer science today. Boole also believed that mathematics should not only be correct but also beautiful. A theorem is most satisfying when it is clear, elegant, and meaningful. For him, beauty in mathematics reveals deeper truth and stronger insight. George Boole saw mathematics as an elegant symbolic language that expresses logic, and his ideas helped shape the digital world we use today. This is Norbert Wiener. He believes that mathematics should not stay inside book or classroom. For him, mathematics was not only a subject to be done in the study, but one to be discussed and lived with. He saw math as a discipline deeply connected to the real world, and he believed mathematicians have the responsibility to apply their work and to consider the moral consequences of those applications. Wiener is also known as the founder of cybernetics, the study of control, communication, and feedback in both machines and living systems. His ideas form the mathematical foundation of many modern technologies, including robotics, automation, artificial intelligence, and digital communication. Through his work, mathematics became a bridge between theory and real-world technological innovation.
This is Andre Weil. Andre Weil believed that mathematics is not a collection of isolated subjects, but a deeply unified field. For him, the biggest goal of mathematical work was to uncover the hidden connections, what he called analogies, that link numbers, polynomials, geometry, and other branches of mathematics. He felt that beneath all the complexity, there is a single underlying structure waiting to be revealed. This vision guided much of his work and shaped his belief that understanding these connections brings mathematicians closer to the real heart of mathematics. Weil is the founder of modern number theory, which is the foundation of cryptography, or the internet security, and later used in coding theory for QR codes and error-correcting codes. Weil further discussed mathematics as an analogy, presenting it poetically. He described different branches of mathematics as if they were lovers, full of passion, mystery, and furtive curses, when mathematicians first discovered surprising analogies between them. But once those analogies fully merge and form a unified theory, the excitement fades. The mystery gives way to clarity, and the relationship loses its drama. Even so, Weil believed that this final unity, though less thrilling, reveals the most profound truth of mathematics. He developed his life to pursuing this unified view, driven by a desire to understand the real meaning behind every fundamental mathematical phenomenon.
And lastly, this is Alan Turing, who believed that mathematics should not be seen only through strict logic. He said mathematical ideas can have different meanings and even define a computer as a person who performs calculation. His thinking led him to create the foundations of computability theory. Turing invented the universal Turing machine, which showed how a computer can follow any algorithm. This idea became the basis of modern computers, programming, and artificial intelligence. During World War II, he also helped break the Enigma code, proving that mathematics can make a real difference and even save lives.
Now, let's reflect.
Perspective is important because it shapes how we interpret and approach problems. Through showing the different mathematicians and their views on mathematics, it allows people to see different aspects of a situation and identify solutions that may not be obvious from a single viewpoint. In mathematics, some focus on abstract concepts, while others emphasize patterns, structures, or practical applications. Having multiple perspectives and views encourages creativity, innovation, and more effective decision-making. It also improves collaboration as understanding others' viewpoints helps people to work together successfully.
How about you? What is your view?